This is the Amp Hour Podcast, recorded September 19th, 2011. Episode 61, Gallimaufry, GaN, Gabble.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble from Chris Gamble's Analog Life.
And this is Jeff Keyzer from MightyOhm.com.
Hey, the gang's
The
back
usual. The usual.
That's like Three's Company.
There you go.
Ed
Yeah.
McMahon's
Or
in the
maybe not.
house, folks.
Yeah. Yes, sir.
I still don't get it. Oh, boy. Anyway.
Yeah. So what's up, man?
Well, what's
you're
up
in New York,
with you,
right?
dude? Come
Me?
on.
What's... Oh.
Tell
I
everyone
am
what
married.
happened only yesterday.
2 days ago. 2 days ago, I
2
got
days
married.
ago, sorry. All right. It was
Yes.
Saturday.
Hey, wait. What? Say that again.
I'm married. I'm now a married man.
You are officially hitched?
I am hitched. It is all done. There's no
Wow.
going back without a lot of legal proceedings.
Right. I had a lot of loss of
There's not like a lemon law or something.
Right.
Lemon law.
No.
That would be an interesting one to bring up to the now wife.
You're a lemon,
I
honey.
didn't quite get what I wanted, so yeah.
Well, congratulations, Chris.
Yes,
That's
thank you.
really awesome.
Thanks a lot. I have a my ring is tungsten. Actually, I've been telling people about this.
Ooh.
No.
And the thing about tungsten is, it looks really cool, first off.
Right.
But the thing that really that kind of sucks about it is it's a little heavier. But
Yeah.
it's if my finger ever swells up, they can't cut the ring off. So they'll have,
You know, I
they'll have
have
to cut
heard
the finger off.
Nice.
I have heard this before. I've heard this before, even about titanium rings, and I don't know if that's really
No,
true.
you can
I'm
get a pair
wondering,
of bolt cutters on there, surely.
Something.
Yeah.
I mean, I would think maybe even shattering it. I mean, you could probably break the finger as long as you're, like if you put a hammer against it. But man, interesting prospect. I got to say that makes it a little more permanent. If I ever have like a real swole up finger.
Right. Good luck with that.
Thank you.
Yeah.
Thank you. Yeah, but all went great. Things went down without a hitch, and now I'm in debt. Wedding economics are not a fun thing to deal with,
Right.
especially as
Yeah. Seriously.
I wrote a post
Yeah.
about it. I'm a cheapskate. I know this. Dave, I think you
Yep.
said you're a cheapskate. Jeff, I don't know about you.
I'm frugal.
Yeah. Okay.
I think most engineers are. I think it's one of our traits.
Yeah. I think so too.
Yeah.
Yep.
Yeah. And I wrote a post about if people would marry engineers, and that was an interesting post. Just hearing everybody's opinion on that, and I'll post a link to that. But it's just it's tough dealing with the realities of at least the U.S. wedding market. Is just really overpriced. I was so glad I did all
Well,
this
your
stuff. But
problem was mentioning the word wedding.
Yeah,
the price
exactly,
instantly
exactly.
quadruples. So you
Yeah.
just say, no, we're having a
completely-
conference or something, and you'll actually get the same room for a quarter the cost.
Yeah.
Yeah.
I know what you mean, Dave. I went through the same thing whenever I got married, so I feel for you, Chris.
whenever
I really
he got
do.
married,
Whenever- how many
I hope
times have you
Kylie
been
did not
married?
hear that. Yeah.
No, just once. But in that one experience, I also went through this. I think there's like a wedding tax on, every especially event venues, like the places where you do these things. They live for weddings. It's like that's how they make all their money, and they just gouge you.
Yeah.
Of course they do.
They're relentless.
Well, it's over now. No going back.
So
No
did
refunds,
this involve Vegas and Elvis, or was
No,
it a bit
no.
less tacky?
No, this was not, I wouldn't say traditional. It was a good time though. It was all around. It was a good time. Some
Excellent.
boozing, a lot of friends. That's the important thing.
And what the hell are you doing here?
I know. Well, that's the real thing. I'm actually I'm traveling tomorrow. So if people don't, I think I announced it on Twitter. I'm actually going to be in Boston Tuesday to Friday this week. So if people are in Boston and want to meet up, give me a shout. Give me an email. You can find my email online. But yeah, I'm going to be out there for recruiting and stuff for my company. So, yep, I can meet up with people.
So you're trying to get those young, impressionable graduates cheap, huh?
Yeah, I guess so. I don't know if anyone comes cheap in Boston. So,
Right. Oh,
Yeah.
is that an expensive city, is it?
oh, quite, yeah.
Yeah?
Yeah.
But $400 for a hotel room, that kind of thing. I mean, it's probably on par with Sydney. I mean, it's
Right.
No, I don't know about Sydney, but definitely
Well, I
large
just paid
metropolitan
$99 a night when I was in Melbourne, because I was in Melbourne
Oh,
for
nice.
a week. And yeah, but that was like a $250 a night room or something. But it was like a dump. It was pretty bad.
Yeah.
Nothing worked
Yeah.
in it. It was hopeless.
Oh. Yeah, especially Wi-Fi, right?
Yeah, especially Wi-Fi. I had to walk around the city and try 4 different internet cafes before I could find one that had sufficient upload speed and sufficient upload stability to actually upload the recorded version of the amp hour. I tried. We recorded it using my mobile phone, as you might know, last week, and as the internet connection for the streaming audio for the show, and it only dropped out about half a dozen times. But I just couldn't upload the 150 meg audio file, and I crashed the Starbucks server. Yes.
Sweet corporate revenge.
Awesome. I paid $6 for the privilege, though.
It really
isn't free. No, it's not free. No, you're going to pay for it.
Wow.
Yeah, it sucks.
That's
It's
too
free
bad.
in America, isn't it? Land of the free?
Some places,
right.
some places. Like airports usually still isn't, but...
Right.
So what about the rest of your trip? I mean, we're going to hear about Jeff's trip. That's obviously why Jeff's on. He's in New York, right, Jeff?
Yep.
Before we get to that, I mean, Dave, what else do we expect to see from you on video side of things?
Okay, I went to the electronics show, and it was good. I only went for the one day, though. I decided to bail on the second day. I thought, I've only got one day left in Melbourne. I want to see some shit, so I buggered off. And I spent most of the time talking to people, getting cornered. You're Dave Jones. Yay!
Oh, yeah?
And a lot of people, I was surprised at the number of people who love the amp hour. They come up to me and said, I love the amp hour. Love it.
Too bad. Yeah,
So-
we need to get like T-shirts or something
I
to give
know,
out if people
exactly.
find us or something.
Yeah.
You know?
Anyway, I was surprised. More people come up and mention the amp hour than they did the blog, I think. So it was great.
Yes.
Yes.
That makes Chris feel better.
Anyway, it was very cool. I interviewed... I actually caught up with Carl, as in Doco Carl von Moller.
Oh, great.
Who's doing
Any
the Doco,
any
and
updates?
I've got him talking about it on camera and where it's at, and
Okay,
he's back
okay.
working on it now. So yes, the Eternal project will happen.
Yes.
And yes, it's all good. It's all happening. It was a good show. It's not big, it's not huge like a big ESC American show or something like that, but it was certainly bigger than the one in Sydney last year. So it's
So what are we talking
growing.
like vendor wise? Like how many booths are we talking?
how many
100
booths? I
booths,
don't know,
maybe?
50 odd booths or something, at least.
Okay. Okay.
So it's quite decent size for a small country like Australia, anyway. So yeah, it's good. I think there
good.
might be more than that. I don't know. I could be talking out my arse there.
Well, how about this? This is how I usually measure it because I've been to a couple different ESCs, but that's about it in terms of conferences. How big was the biggest booth? Because when I went to the one in Silicon Valley, I was impressed by how monstrous like the Green Hills booth was and like the Microsoft.
No, this was a small hall. It was part of the Rod Laver Tennis Centre. If you're into tennis, you might know that. And yeah, no, it was only small. So the stands, the biggest stand was, I don't know, not much bigger than my lounge room or something like that. So
Okay.
yeah, certainly not on the huge scale. That was they actually I talked to the organisers and they complained that they actually ran out of room there. So they're looking forward to Sydney next year, which has a bigger space they can expand into, so they can offer bigger booths and things like that. Booths? I said booths there, didn't
Booths.
I? Bigger booths. And it was good. And I also went to EMC Technologies. I've just uploaded a video last night of how they test mobile phone radiation. This cool little $1 million robot arm, which with a EM field probe, and it senses the EM field around a mobile phone. It's very cool.
That is cool.
Yeah, I like it. So watch it. It's just uploaded last night, and they showed me their $1.8 million RF test chamber, which is the biggest in the Southern Hemisphere, and it's very cool. You've got to see footage of that. It's hard to capture on camera because it's so massive in scale.
So this is like one of those big rectangular rooms that has the little triangle,
the little triangles,
like little cone things
and
on
it goes
right?
from DC to 40 gig, yeah.
Oh,
So
wow.
40 gig.
That is crazy.
And they do it without the RF tiles, like normally. The ferrite tiles. You'll see all this on the video when I edit and upload. But in a normal RF anechoic chamber, those little triangles are so short, they can't make them long or deep enough that they have to completely surround or encase the room in these ferrite tiles. So they screw all these ferrite tiles everywhere, and it costs a fortune. That's why these test chambers are very expensive. But this new one that they've built is so massive that they're able to make these cones like 2.2 meters deep. They're huge.
Wow.
And what's that, 12, 13 feet or something deep, these cones. And so they're so deep, they don't need the they don't need the ferrite tiles on the back of them.
2 meters? 2 meters deep, Dave?
2.2 meters deep. Yep.
Yeah, it's only like 6 to 8 feet.
Yep.
That's
Something
not
like
12.
That.
Still
Still monstrous. That's taller
they're
than I
big
am,
cones. Trust me. When you see,
It's like putting Chris Gambles around the room, just shooting out from the wall, perpendicular to the wall.
and it's so big they can drive a truck in there, and they're going to install a turntable and a dymo as well, so that they can have the car actually running inside the chamber at full speed and bombard it with EMC. Oh yeah,
That is really cool.
It is very cool.
Did you get to see any live demos?
No, unfortunately, they don't let me shoot the live demos because they're customers' equipment and stuff like that. So, pretty sensitive stuff, and they've got military contracts and other sensitive customers who shall remain nameless. So,
Right. Makes sense.
Yeah, it was very cool, and they showed me that around at the last minute, and so that was good. That's coming up. I also talked to Colin Hitchell from Talking Electronics fame. You guys won't know that, but everyone in Australia will be very excited to see an interview with Colin Mitchell.
You mentioned that last time. I looked up his site, but I didn't quite get it.
His site is very old school in terms of old school HTML.
Like GeoCities style.
GeoCities kind of, style. But there's a wealth of information in there. If you want a transistor tutorial, he's got 100 or 150-page transistor tutorial. Download it. Fantastic. The content is
link that in.
Massive, yes. So I interviewed Colin. He's a very interesting guy about the history of Talking Electronics magazine, which was big in Australia back in the 80s when I was growing up. So, yes.
That must have been kid in a candy store.
Yeah, it was kid in a candy store. Yeah, he showed me some old prototypes and stuff like that. So yeah, and he's one of the guys who taught me. So through his magazines and his books and things like that. So yep,
that's awesome.
If you want to know where I learnt electronics, it's Talking Electronics.
That's
Colin
great.
Mitchell. So.
So
yes,
Jeff has been spending his time apparently in a cave. We can hear that right now in the background. Apparently there's gremlins or some kind of wind tunnel action. Not anechoic so much as echoic.
Echoic.
Yeah. I have a sound reinforcing recording studio here. I'm actually in the Upper West Side of Manhattan right now, so you get to hear the sounds of New York City in the background.
And the smells as well. Is this Smello radio?
Yeah, it's actually it's quite pleasant up here. This is a nicer part of the city, I think. So we actually we're in pretty nice accommodations here, and
that's one of the things I found when I visited New York was the smell. It's a very smelly city. It's a very...
It definitely, there's kind of a lot of everything.
Yeah.
So you get to see the dirty underbelly of the city just walking down the street. You get to smell the dirty underbelly, I guess. But I was
That's
actually...
a hobby of mine, smelling underbellies and smelly and nice ones and not so nice ones.
Does your wife know about this?
She will now.
Oh, boy.
Yeah, but I'm actually out here for the, two things. I came out here for the Open Hardware Summit, which was last Thursday. Yeah, and also the New York Maker Faire was this past weekend.
Yeah, so, that was like the World Maker Faire, wasn't it, or something?
Yeah, I guess they call it the
They sort of bill it as the World's Maker Faire.
I think they're riffing on the fact that it's at the world's fairgrounds from 1960 something. Right. Yeah.
And we'll remind people that if they don't know it, but they know popular culture, that's where the the first Men in Black video, where the alien actually climbs up into those saucer-looking disc thingies.
Is it?
That's
right.
at that site. Yeah.
Really?
Okay,
I had no idea. I didn't realize that, but I was right next to those, and there's the big globe with the fountains around it, and
Right.
you know, the whole thing.
They crash into that, yeah. I think I mentioned that in Amp Hour 10. I think that was back in that time frame.
Okay.
So we've been doing it that long. That's how much Amp Hour there's been.
Wow.
Yeah, it's crazy. The 1 year
Wow,
point.
what's up, boy?
Yeah,
There you
right.
go. Somebody's shouting off bingo right now.
Oh, yep.
Yeah, I guess we should give a shout out to all the listeners who are playing along with the show.
The AmpHourBingo.com.
Amp Hour Bingo.
Bingo.
And Roel
Yeah,
and
yeah.
yep.
It's been a really amazing trip, and I have to say I'm pretty worn out. I've been traveling almost continuously since Chaos Camp back in August, and this is pretty much the end of a long series of trips for me. Then I'm going home tomorrow, actually. But yeah, what a week. The Open Hardware Summit, which I guess as you would expect was awesome. It's interesting. I am the kind of person, I will freely admit, I've been to a lot of technical conferences over the years, and I very rarely go to the talks. I think I've mentioned that on the show before. I'm not one to go to the talks. They're usually boring.
Same here. I'm not a big...
They're usually companies, they're usually these things that are incredibly technical, interesting to only people who are working intimately in the one particular subject that they're about, not of interest to, people like me who are just casually just checking out, what people are working on.
And these things aren't short either, right? Some of them can go all day. Like at the Melbourne conference, I wanted to shoot some, they'll do some great tutorials.
So this conference, the Open Hardware Summit, was targeted specifically for people with attention deficit disorder, because I don't think there was a single talk that was more than 10 minutes long.
Oh, wow, really?
They were all super short, which in some cases was a little bit frustrating, because there were a couple that there was a lot more. So there were, I think what a lot of people did is the guys that got invited to the summit, and I really don't blame them for this, but they'd made a presentation for the Maker Faire, and then they shortened it for the summit. So there were 3 or 4 presentations that they said, we had to skip a few slides, but if you come check us out over the weekend, we're going to be at the Maker Faire. Well, it's not really great for people like me, because anybody who's ever been in the Maker Faire knows that if you're manning a booth, you don't get to see anything, right? Like you really don't. You don't have time to go and see talks. So I guess I appreciated getting like the sneak peek, but there were a couple talks in particular that I really would have liked getting the entire talk. So maybe some feedback to the Open Hardware Summit, and I'll be talking to them in the future. Is really that try to give a little more talk, and I think maybe they have to make that fateful decision of breaking the talks into 2 separate tracts, because
or extending the days, which would be another one.
Yeah, and I think there was easily 2 days worth of material.
I think increasingly that there will be,
And I can only imagine next year. So there were, a couple dozen talks. There was a single track all day, except in the afternoon there were breakout sessions. And I have to say that I went to all the talks. I sat through all of them, and overall, they were great. I mean, they were really interesting. And there were actually a couple talks that I really enjoyed that I think are probably also of interest to our listeners. And, of course, the Arduino team gave the keynote. So there was a really interesting talk about the Arduino team by the Arduino team, where they talked about, where they've been and the process of developing the Arduino. And they apologized again for that pin spacing issue that everybody gives them a hard time about. And really the message, they had like a 10 different points about engineering or open source hardware design. And one of them was like, I forget, like the biggest things are always like your mistakes, like the things that people will criticize you the most and think that you were maliciously trying to control, the market, are really usually just attributable to like mistakes, right? So that's the case with the pin spacing, is somebody made a mistake, and now the shields all have that weird pin spacing on them. But anyway, that talk was really good. Bunny Huang, I guess you say it. He's the guy that did the Chumby. He gave a really interesting talk, and I see, Chris, you actually put some words about it here in the show notes.
Yeah, I got a chance to watch. I was watching streaming, and I was like, man, if they get this better next year, I don't have to go at all. I'll just sit here and make snarky
Well,
comments on
watching
Twitter.
this
And
streaming, Chris.
yeah, I was mostly
Wasn't
listening.
your wedding on?
No, this was on
No,
Thursday.
this was last Thursday.
Yeah, I was sitting at work and I was like doing
okay.
work and I was like just had on my headphones and I was doing some like spreadsheet type work and it was, kind of the stuff I was doing at the time wasn't that intensive, so it made sense, right? And
Right.
Yeah, and actually what's a little bit tragic is that I think they were streaming, but I don't think all the talks actually got recorded. And I don't
that's too
think
bad.
that they
That's a
had
shame.
a full recording set up at the conference either. I was talking to somebody over the weekend who was saying that some of the talks may have been cut off because of technical problems, but it'd be a real shame if not all of them were available, because I'd actually like to watch some of them again, just because I felt if you sit through that many talks, sometimes you have trouble picking up all the details. But
and Massimo Banzi also said that too. Someone asked him and he said, I got the chance to see the Arduino, the keynote too, and he said, someone asked, well, where are you going to release the slides? He's like, yeah, I will, but they're just basically keywords. They're not, you got to kind of hear the talk.
Yeah.
Yeah,
So you can't
and
just
it's true.
look at the slides.
I feel like high definition video recording should be a requirement for a conference like this, and I think I'd actually pay more if I could get videos,
like a DVD
because,
almost.
Or
streaming
well,
video.
I mean,
Well,
what I'd
it's
really
not
like
hard
are just
to set up a decent camcorder and a wireless
well,
mic.
you
You
have
They
to
should probably
realize
send
like,
Dave Jones next year.
Yeah.
We should probably just do that. Have Dave kind of report on the whole thing.
This conference was run, I think, on a very tight budget,
Yeah.
and I think that the number of people that were involved was very small. So I can understand if it's hard for them to do that. But I'm hoping that next year maybe they've got maybe somebody can be specifically responsible for doing videos, because I think having HD videos of the talks should be a priority.
Yeah.
But back to where we started. So Bunny gave this really interesting talk. Wherein he states that because of Moore's Law, and rather not Moore's Law, but the breakdown of Moore's Law, which I think he's predicting is going to be in the 2020 to 2030.
No. He was saying some people say. I said that on Twitter too, because he didn't want to be misquoted as saying that because he didn't want to be like on that list of people that claim the end of Moore's Law.
On the other hand, the premise of his whole talk was this breakdown of Moore's Law, right?
Which I argue against, I think, but
yeah, and I actually don't know if I completely buy what he was talking about either. So basically, he's proposing Moore's Law will break down, and people will start hanging on to their electronics. Like, you'll have an heirloom laptop that gets passed down from one generation to the next, because innovation will slow to the point where manufacturers won't be able to come out with new products every year because scaling won't work anymore. You won't be able to get 10 times the memory next year that you had a couple years before, and so because of that, an entire industry will develop surrounding repair and maintenance and upgrading computers that were manufactured several years ago. And I actually don't buy it at all.
I don't buy it at all because the prices are at a point where, a decent notebook is like $400. You got to be kidding me, right? If it breaks down, people just go buy a new one. As long as I think our affluent society keeps up, then...
Yeah, and I agree with that. And I also think that if Moore's Law does start to slow down and you don't get 8 gigabytes of RAM next year where you had 4 gigs the year before, I think manufacturers will find other ways to differentiate and improve their products, right? Yep. Like I could absolutely imagine that instead of the CPU wars, which are over, by the way, because now gigahertz. He started the talk basically saying that computers have been at 3 gigahertz for over a decade now, right? Like computers have been at 3 gig for a long time. But I think that we're going to see other things like the battery wars. For example, power consumption will become a big spec, and it already is. But if you don't
Solid-state
have
hard drives will be huge.
Absolutely,
right?
Integration will be big too. Like moving everything into one piece.
Power supplies will be a big thing.
Yeah.
Low power, low, fanless, no noise, stuff like that.
So I think that manufacturers will always find something to innovate, and I don't know if that's necessarily going to change the fundamental nature of the relationship of people like open hardware. The guy in his garage, fixing laptops. I think it's going to be pretty much the same.
It's got
10 years or 20
it,
years or 30 years from now. But it was kind of an interesting message, and I think there were a couple interesting things to take away from his talk, and really the thing he was pushing was that it's tough to compete with a large corporation that's basically taking advantage of Moore's Law. They can work so quickly and they pipeline their product development such that they worked with Moore's Law basically to their advantage, right? So they're able to move products quickly enough that next year they've got a product that is so much better than the one before that somebody working in their garage has no chance of keeping up with that. Somebody in their garage can develop a motherboard.
It's crazy.
Well, I don't know if they shouldn't try.
You're not smart
but
if you try and keep up with the big boys. I mean, that's just crazy. You've got to be smarter than that.
I think that, and I think it's all about you can't develop motherboards in your garage, for example, because by the time you develop the motherboard and test it and release the design, it's obsolete. But
and
there's
that's
always going
ignoring
to be
the fact that these motherboard manufacturers have deals and companies have deals with early release stuff anyway.
Oh, of course.
Stuff you'll never get.
Yeah,
you'll never
that's
get
right.
as a small player.
They effectively just cut the individual maker out of the whole equation, right? There's not even a chance. But I do think that it's an interesting phenomenon that he points out is that how Moore's Law basically makes it impossible for the guy in his garage to really occupy the same industry as some of these big corporations. But I think that instead of waiting for Moore's Law to crap out, perhaps it's a better idea to just try to position yourself in the industries that big corporations are not good at servicing, right?
Well, that's always been the domain of the midnight engineer.
Yeah,
always has,
exactly.
Always will.
Exactly.
Yeah.
But, I got to say, so maybe I disagree with some of the fundamental points of his talk, but at the same time, this was just one of many talks, actually, at the Open Hardware Summit that I thought were really interesting. And it gave you a lot of things to think about. And Amanda Wozniak gave a good talk also about open sourcing the engineering process. And she was basically pitching documentation, like saying, you're just one guy and you're making some stuff and, you know what you did and you know why you made your design trade-offs. And so you don't bother to document any of the things like why you chose a particular transistor or, why you chose to make a decision in your design. Well, she's saying that down the road, you need to be able to reuse your existing projects to make new projects. And without documentation, it's very hard to do that. So I thought that talk was actually pretty interesting. But one of the talks that I thought was really interesting was the Nathan Seidel from SparkFun gave a talk about where transparency ends. And SparkFun is, cited as one of the big, the world's most successful open hardware companies, right? I mean, they're, a $10 million, $14 million business at this point. And he had an interesting point, which was whenever you're running a business, where do you draw the line? Like, what are you not transparent about? And his point was that anything that doesn't directly benefit the customer, there's no reason to, right? I mean, you're not helping the customer, and you're actually hurting yourself because you're essentially giving other people a recipe book for creating competition, right?
Like how much profit you make, what's your profit margin, and what are your volumes,
your suppliers,
like
and your accounting details, how you do your web store, all the things that just are behind the scenes, shipping and receiving. It's all that stuff that really doesn't matter. And I think it's interesting because you need to. I mean, we're doing open hardware, and everyone tries to be, as transparent as possible. But if you're running a business, there do have to be some limits to the transparency for you to remain a business, right? So I think, and there were a lot of other really good talks, a lot of interesting speakers. But I had a great time. I thought it was just really good, really definitely worth my trip out there. And one of the other things that I thought was particularly interesting about this year. Now, I have to say I didn't make it to the summit last year, so this was my first year. But last year, I remember the big buzz was about the open hardware definition, right? Last year was the release 1.0 of the open source hardware definition, or whatever what it's called. And this year, there were a couple talks, not a lot, but a couple talks about open hardware licenses. So that's the next step, right, is you develop the definition, and then you've got to develop licenses that people can actually use on their products that, support that or, are compliant with that definition. And one of the interesting things about this year was that there were two talks about licenses, and both of them, I actually got the sense that it was more they were soliciting recommendations. They were looking for feedback on some beta licenses, right? So last year we didn't have any
CERN,
licenses.
Maybe? Or
Yes, CERN was one of them, and then Ohanda, Ohanda, was the other one. So last year there were no licenses featured at the summit, right? Or maybe there was GPL or Creative Commons.
Right.
And then this year we've got a couple more, but they feel kind of beta. So I'm actually wondering if maybe next year, we actually do get a license that we can just put the stamp on our product and not have to really think about it as it is right now, where you're like, well, am I going to use Creative Commons? Am I going to
so
use
many of them. It's very confusing.
The Tapper? There are a lot of them. And very few of them are actually have actually been tested in the legal system, right? And that's what matters more than anything else is, you can put any license you want on your work, but
does it, right? Because people who develop open source hardware products, right, they're the midnight engineer, they're in the garage. They don't have the money or the inclination to go out and sue somebody, right, to engage lawyers and do all that sort of thing. So it's almost like, you could get away with, as back in my day when we open sourced, in quote marks, something, it was just like it was like a handshake thing, it was just...
I know what you're saying, but then again, we do have some companies like SparkFun and Adafruit who are growing to the point where maybe they could actually go to court if somebody stole...
Or they could get their ass sued, either way,
Oh, absolutely, right. So, I don't know. I know what you're saying, and I agree that, if somebody stole one of my products, I'd have a hard time doing very much about it.
And you wouldn't bother, because it's not worth your time or money. And most people realise that. It's just not worth it.
There are groups like the EFF that fight for the individual
but only
digital
on the big
rights
scale
organizations.
Stuff. They
You'd be
can't afford to
surprised
take on every...
If they can get a lot of publicity out of it.
Oh yeah, of course. But that's what they have to get out.
You never know.
They if you're just one guy that nobody's ever heard of, they're not going to take on your case. I doubt it.
So. I know what you mean.
Yeah.
But I have to say, overall, the conference was definitely it was great. I'm really happy that I came out there, and the Maker Faire was great too. I was
surprised they did overflow stuff for the open source hardware. It seemed like they overbooked almost even.
Well, I think they have a very limited capacity because of the venue. There's an auditorium that's actually pretty small, and it was packed, like people standing in the aisles and stuff.
Right.
So I think they knew that they were going to go over capacity, and I think that they're somewhat limited because they can't really go to another venue without losing the ties they have with the Maker Faire. I think the Open Hardware Summit benefits a lot from being held in conjunction with the Maker Faire because a lot of people are here anyway.
it was at the same location, was it?
It was at the same location, and I think they shared some services too.
Right.
I think they were basically riding on the the coattails of the Maker Faire.
Well, that makes sense, because you can save a lot of money that way. So
yeah, that's right. So I don't know what they're going to do next year, but I hope that it continues to grow. And it was great because I got to see and meet and talk with a lot of people in the open hardware scene that you only see online. You get all these people in one place for even just a weekend. And
it's trippy, right? When you meet everybody in real life. Yeah.
And I have to say that at the Maker Faire in particular, I had quite a few people come up to me and say, "Aren't you that guy from the Amp Hour?"
No, I'm from MightyOhm.com. That's another Jeff Keyzer.
I don't mind. Yeah, I don't mind.
Wear a big T-shirt next year, Jeff. It just says Mighty Ohm.
Or I am not from the Amp Hour.
Well, you should say Mighty Ohm and then maybe in parentheses down at the bottom, the guy from the Amp Hour.
Or how about just a big picture of Ed McMahon?
Oh boy.
I'll stop doing that eventually. Don't worry.
I thought it was a great thing to come out for, a great weekend. I'm glad I came, and Maker Faire. If anybody that hasn't been to a Maker Faire that's listening to the show,
I'm putting my hand up because I'm in Australia.
There were people,
it's like
on
the other side of the planet.
My booth was actually next door to a guy who came out from Manchester, England.
Oh, there you go.
Yeah, there are people traveling. It is the World Maker Faire, Dave.
Yeah.
There you go. Next year, Dave. And I haven't been either. I should say, too, I don't want to be a hypocrite here. I haven't been either. So
there you go.
I couldn't stick around last year, and I had an excuse this year. So at least on the world side.
Yeah, there were actually a couple pretty exciting announcements at the Maker Faire too, and I won't harp on about this too long, but I think the two big ones the one really big one is that the Arduino team announced that first of all they're going to 1.0 of their software. And apparently there's a bunch of minor features that they've introduced. I think they're mostly just bug fixes and stuff like that. But the real news was in hardware. So the Arduino group is releasing a couple new boards, at least 3 new boards that I know of. There might be more. And one of them is called the Arduino Leonardo. And it is an Arduino based around an Atmega 32U4 microcontroller that includes the USB functionality in the same microcontroller as what's running the Arduino code. Oh. That's a first. That's a first for the official Arduino team. Previously, there were products like the Teensy, done by PGARC, I think it is, which is the same kind of deal. But the real big news is the Arduino Due, I guess, which is an Arduino that runs on an ARM Cortex M3 running at 96 megahertz. That's a big deal.
So why is that such a big deal? And also for posterity, I'd like to say 555 to help people on the bingo side of things.
Right, yep. I was going to say that.
Well, it's a big deal because this is a first for the Arduino team. There's been a lot of other groups that have tried to make like Arduino compatible or vaguely Arduino-like boards that contain ARM Cortex processors.
And what's wrong with that? That's the whole idea. Arduino don't own this. It's open source, right?
Well, the big deal is that they were never quite the real deal. Right, they were never quite completely compatible, and
what's the real deal? If you fork the Arduino code or something, and you put in your own, support for your own board, why is that not as legitimate?
The big deal is that it. Well, okay, I don't care about legitimacy, but the real deal is that if you're some guy and you do this, you're not going to get the community involvement that it happens if the Arduino team actually does it. I mean, that's really what this comes down to.
Granted.
If Arduino does this, it's going to be a big deal, right? Because everyone's going to say, oh, okay, yeah, there's an ARM Cortex board that's running Arduino. I'm going to check that out. You're going to have a lot of community involvement. You're going to have a lot of shield development. If you're just, some guy in his basement, or if you're some company like ARM that does a board like this, like there's the Embed, right? Which is like sort of Arduino-ish, and it's got an ARM processor on board. And, I don't know if I've ever seen a project in person that uses the Embed at something like the Maker Faire. I'm sure that they're there, but I think now you're going to see a lot of boards with Arduino, with ARM processors on them because of the Arduino Due. And I mean, this thing is kind of a beefy board too. It's like the Mega, but it's got like a whole bunch of UARTs. There's a 3-wire interface. They've got a whole bunch of stuff that comes standard on this board.
That's interesting from a supply side too, because you know how getting 320. A lot of people who are developing for Arduinos, they complain about not being able to get it at Mega 328.
Yeah, although I gotta say, they are using Atmel processors for everything. So they're using an Atmel ARM core processor.
Yep.
I think the Arduino is in cahoots with Atmel. Maybe they have been for a while, but Atmel was actually present at their booth. I didn't have a chance to really check it out, but I know the press
marketing.
It's
marketing, right? It's awesome for them.
If you look today, there's press releases all over the web that are like, Atmel and Arduino working together, blah, blah, blah.
Yeah.
I do wonder about those supply problems because, I wonder if these ARM processors are as hard to get as the Atmega 328s are. You got to wonder. But I think this is interesting stuff. I don't know if I'm going to run out and buy one of these ARM Cortex boards, but maybe I will. And I think it's interesting because this is the first time, I believe it's the first time that the Arduino team is releasing an official board that doesn't use an Atmega processor, right? So that's kind of a big deal. So it'd be like them,
doing
Arduinos,
I think we've lost half our audience because we've just been crapping on about Arduino.
But I gotta say, if I was one of these companies making PIC-based, the chip kit boards, I would be nervous, right? Because here's the Arduino team coming out with their own beefy board with the Mondo, big processor. These other companies that have for a long time been pitching, we've got this, you can run it X hundred megahertz and it's Arduino compatible, but you get Ethernet and all this stuff. Well, you guys better watch out because the Arduino team seems like they're pursuing this as well. And I think anything Arduino does is going to end up being, eventually, unfortunately, sadly for these other companies, anything Arduino does, it's going to be like Apple, doing their version of it. Of course, everyone's going to use the real, the brand name thing.
It's like when they pull in like apps into their actual like distribution or into their actual operating system, right? They say, "Oh, we like that feature as an application," and now, "Oh, hey, it's part of the operating system." What do you know?
Yeah, Twitter did this with what was it?
TwitPic.
That's no. Well, actually, that's a good point. TwitPic, but they've also done it with clients too. Like Twitterific, I think became the official Twitter client for iPhone. So the company gobbles up. Or
like the link shortening stuff. Yeah, it's the same.
Yeah,
thing.
exactly. Yeah. So I'd be nervous if I was developing an Arduino board that wasn't made and I wasn't Arduino. I would definitely be nervous because they could easily put some small company or small guy in his garage out of business, I think, if this is the only industry.
Yeah, it's tough that it's a smaller industry too, because in other industries, if it's a bigger game, right? So if it's instead it's like CAD programs, right, or EDA programs, then it's not we're taking your features and rolling it into ours. It's, hey, we're going to buy you for millions of dollars. That's not going to happen with these small microcontroller companies.
Yeah, well, it's more like we're going to make our own, and you're irrelevant now.
Right, exactly. Right? And for bigger companies, it's just easier to buy the smaller company and try and pull them into the culture.
But with open source, you don't even have to buy them because if they don't have a non-commercial clause in their open hardware license, I mean, not that anyone is doing this, but if you were the big company, you could just pick and choose from the open hardware designs. And that's something that I've been thinking about lately, and I'm not sure how I feel about I know that this has come up on the show before, but the lack of a non-commercial clause in the open hardware license, I'm a little curious where this is going to go. I think it's all fun and games until somebody gets hurt, right? And
someone goes broke. Yeah.
Everybody's playing pretty nice at this point, but you got to wonder what the first big thing is going to be. Where a big company comes and scoops up an open hardware project, and the person who developed it ends up getting the short end of the stick, and then. I don't think
company makes millions of dollars.
Exactly.
Little company
Exactly.
Cries.
Yeah.
Yeah.
So anyway, sorry, right. I pulled the show, said the A word
we knew
a bunch
it was
of times.
Happen, Jeff. It's
I think if you don't want to talk about Arduino, you just can't have me on the show. It's pretty much.
Yeah, that's the problem. Yeah, because we've been slapped over the head before for talking too much Arduino. So no more.
Well.
No.
I mean, I'm interested in the open hardware stuff, but
and open hardware too. People say we talk about too much Arduino, too much open hardware. Yeah, so let's do regular show stuff, shall we?
Yeah,
regular show stuff.
Yeah,
we have any shout-outs?
I won't say Arduino anymore. Arduino.
Chip kit.
Shout-outs.
Chip kit.
Shout-outs.
So I had a shout-out. I'm not sure how much I'm shouting about it these days, but engineering.com, they have videos, and I forgot where I'm guessing it was on Twitter. I saw This Week in Engineering. Have you guys ever seen these videos before?
No.
I think I had a look at one once.
It's kind of like a news brief, like a hey, here's what's going on. They're trying to be fun. They're trying, it's like it's interesting. It's I can't imagine, what and they're getting like 6,000, 3,000 to 6,000 views depending on what it is.
Well, if you can believe the numbers, but that's a decent number of views.
It's YouTube based.
Oh, okay, right.
Yeah, it's YouTube based. So it's cool. You got to believe that, right? And so pretty cool, but not bad. I didn't know about it, so I thought I'd give it a shout out. It's cool that.
So it's their own produced show. They're up to episode 74.
Yeah, like 5-minute blurbs. 5-minute blurbs.
Oh, okay, right. Okay, are they highly polished? Like, as in production values?
Yeah, they're pretty highly polished. Yeah.
Yep. Well, then I can understand the amount of work that goes into them. Then.
Yeah.
Good on them.
Yeah.
Check it out.
People should check it out. Maybe if you got, I think in a podcast type format, if you do have like an auto download, it might be kind of fun thing to watch on a daily basis. But I'm personally more of a grazer. I don't do like religious downloads of podcasts. It's more like, hey, I'm doing something now. I should think
who's
to
the
download
host
a podcast.
on this?
It's two guys. I'm not sure their names.
Right.
Yeah.
we should give a shoutcast.
Dan Hedges
I ran
and
into,
Vince. Hang on, I got them.
Oh,
Dan Hedges and Vince Penman. There you go. They're the hosts, by the looks of it. I just played one.
have you guys mentioned?
And they've got an intro. I still don't have a cool intro.
You may never.
Have you guys ever mentioned the Open Hardware Junkies podcast on the Amp Hour?
No.
No,
I haven't heard about that.
These guys came up to me at the Maker Faire, and I have to say I haven't listened to their show, so it could be total crap, but it's probably not. They're the Open Source Hardware Junkies, or maybe their banner says Open Hardware Junkies, but it's opensourcehardwarejunkies.com. They have a podcast about
It rolls off the tongue, doesn't it?
Let me
it
guess,
really
open
does,
source
yeah.
hardware.
So it's like us this week.
I thought we weren't going to talk about this.
That's okay. This is a potential friend of the show. So
Right.
yeah, that's good. That's good.
Yeah.
Awesome. Check it out.
Jeff's doing construction now, apparently.
Right, was that a truck backing
the
up
New York
into his
soundscape, huh?
apartment?
Yeah.
You can fix all that in post, right?
Yeah, sure.
No, we just don't bother.
I got so much time these days, Jeff.
Right, yeah. All our free time.
So, speaking of conferences, I'd like to bring up one of the conferences. I was actually just at a conference, and I thought it was pretty cool. So I was at a silicon carbide and gallium nitride conference here in Cleveland.
Oh, bunch of funsters.
Yeah, it was kind of it was a dry crowd. I'll give you that. But I got to hear some really cool talks, and I'd never been to an academic conference before. And silicon carbide is meant for like high temperature stuff, so there's a lot of like military people there, a lot of high reliability, that kind of thing. But gallium nitride, man, that is some cool stuff. Just as an elemental, or as a material to use in semiconductors. Mm-hmm. It's just like some of the things they're looking at doing with it. They were talking about, it's such low on resistance. So you make a FET out of it, whatever you want to do. You make a FET out of it. You can make it so small, and the on resistance is so low that they're talking about future generation stuff of pushing gallium nitride transistors and whole switchers into FPGAs. So single die solutions.
Cool.
Yeah, it's so cool. So basically the way it would work is you'd make your FPGA, or as you're making your FPGA, off to the side then you'd have like a little a grouping where you'd grow like a layer of epitaxy, right? Which is like a separator. You grow this area where you're going to build your circuit in silicon, or in this case gallium nitride, and then you build the circuit on top of it. So the circuit they're building though is going to be like a 30 megahertz switching circuit. So 30 megahertz means basically you're using like parasitic inductance, parasitic capacitance, and it's so small that it's all chip level. So they're talking about like 88% efficiencies on chip power conversion.
But you can't do digital circuits on gallium nitride, can you?
I didn't
Can you
think
actually?
so. I'm
I'm
sure you can.
High
There's
level
probably
integration.
I didn't
I mean,
think
the
there was
level
much
of
point to
integration
it.
is probably really
Well, that's
low.
why you do like an epitaxial growth, right? So you have this area of where you're growing, this different kind of circuit.
Right,
there.
so this is just a way to put power electronics onto, say, an FPGA. Is that
But
what you're talking about?
our gallium nitride isn't lattice matched with silicon, though. Like you can't grow GaN on silicon, can you?
No, you grow some intermediate on top of it, and then you deposit GaN, I believe.
That sounds expensive.
It sounds very
Well,
exotic.
now
yeah.
it does. I don't know.
It doesn't
I mean-
sound mainstream.
I'm not getting into the details of that. What I'm saying is they're going to be doing 30. Like right now, you top out. You see like 500 kilohertz. Switch mode power supplies right now. So you'll see like a beefy inductor switching like an amp of current, and you got the big diodes and everything like that. They're talking in 20 years that you won't even see power electronics anymore because it's going to be switching so fast that it'll your inductor won't have to be that big, and you'll still have these amazing efficiencies.
Well, it's faster than light, man.
But
wait, I don't get it.
If you increase switching frequency, that you
The
still
losses are so much lower, though. That's the other thing. So, like, it
Well,
does
they
100
have
volts
to be.
per nanosecond switching. 100 volts per nanosecond. So you don't have that linear region anymore. It's amazing.
And for our audience who aren't aware, as you go up, for a switch mode power supply, as you go up in frequency, you start hitting a brick wall where the losses, all the parasitic capacitance and the parasitic inductance in your layout and all your components becomes much, it just becomes too much, and there's no point going up in frequency anymore because your losses, there's a curve which peaks and then goes down in your efficiency curve as you go up in frequency. So there's that sweet spot of where you can operate at.
Right.
You sort of hit a brick wall if you go too high. But there are advantages to going higher in frequency, as you said, like the components become much smaller. So you only need tiny inductors, or you can use parasitic inductors.
You could do board-level inductors just doing a loop on a board kind of thing. Right.
So if you design like a 15 kilohertz switch mode power supply, you need these huge inductors, these massive, white hand-wound things which take up half of your board space. But as you push your, as you go up to, say, 500 kilohertz, or basically a meg is, or maybe several megahertz is basically the highest that most commercial switch mode power supplies go to now. And as you go up in frequency, you can use smaller inductors.
Yeah, I've done 4 megahertz recently.
4 meg, okay. Yeah. But that's pretty much the leading edge kind of, maybe there's some exotic ones which go higher, but just for your general purpose. DC to DC.
Right, you're right, because in silicon right now, the switching losses dominate.
It dominates, yeah.
Right. But gallium nitride, that's another cool thing, though. I mean, if processes get good enough, then eventually you could switch even, microcontroller processes over to that, and then your switching losses go down, and you could, there's a power equation right now, right? So it's basically, what is it, like frequency of the switching squared times voltage times something else. I don't know the equation offhand.
Yep.
But basically there's a frequency component, a voltage component, and everything else. So they try to optimize with lowest core voltage on chips these days. Not putting your switching frequency too high, and so you don't burn so much power. So if you lowered your switching losses, though, you could ramp your power. Like Bunny Huang was saying, it's a 3 gigahertz. It tops out at 3 gigahertz right now. Well, if you made that whole thing out of gallium nitride in the future, maybe you could push it to 10 megahertz or 10 gigahertz without the same kind of losses. So
maybe, but I think it's a very exotic technique that they won't.
But I don't even know if you get. Do you get P-channel devices in gallium nitride? Because I know. I know with gas, you don't get P-channel devices. It makes designing circuits somewhat difficult.
Yeah, you're right.
Yeah, I don't know. A lot of these heterojunction devices, like gallium arsenide and gallium nitride, they have really, really good properties. And I know that gallium nitride has made inroads into like RF circuits over the past decade. And what's interesting is that whenever I was in grad school, around 2000, 2002, GaN was like the thing of the future. So at that point, GaN was, and in fact, I bet they still are having a lot of issues growing good purity gallium nitride substrates, because the big problem with gallium nitride is defect density, or at least it was the last time I looked at it.
No, it still is.
Okay, so they're still working on that. So for whatever reason, and what's interesting is I don't know how many viewers are familiar with like LED technology, but back in 1999, 2000, blue and green LEDs came out, right? Dr. Nakamura at, where was he? I can't remember. He ended up at UC Santa Barbara, but before that he was at, Hitachi or somewhere, Fujitsu. And he was working on LED technology and gallium nitride. And I remember it was like day and night. Like all of a sudden, one day, there were really, really, really bright blue and green LEDs.
Yeah.
Right? And I was in college. I was an undergrad. And I remember these things just popped up. And they were on the surplus and, hobbyist market in no time, right? People were like, oh, crap. Before that, it was for blue LEDs, it was silicon carbide, right? And they were always really, really lame.
Yeah.
And then it wasn't, they were really dim, and then all of a sudden you had these high brightness LEDs, and then the next thing that came were the white LEDs, right? And this was all because of gallium nitride, right? And I think within a short time,
listeners should know that's all because of band gap stuff, right?
It's all because of band gaps, yeah. And the interesting thing about LEDs is that for whatever reason, they still work really well if there's a high defect density in the substrate. So you can make really crappy gallium nitride material, and this is my understanding of it. and you still get pretty good LEDs. You don't get very good lasers, I think. So that was a difficult one. And you also don't get very good RF devices. And so the big deal in 2001, 2002 was how can we grow better gallium nitride substrates in order to make good RF devices. But I think since then, they've overcome some of those issues, and companies like Cree, there's other companies doing gallium nitride, have started making inroads and replacing things like LDMOS, which was the silicon-based technology that was used for power amplifiers for cell sites and stuff like that, with gallium nitride. And gallium nitride has, as you were discussing, it has that huge advantage in that it can handle huge amounts of power, and the frequency breakdown voltage trade-off is really, really good for gallium nitride. So there's this fundamental limit of how fast you can make devices operate and the breakdown voltage. And that's why silicon isn't used very much in high power amplifiers for radio frequency work, and that's why gallium arsenide is used so much in cell phone power amplifiers and specialized military stuff. So GaN is like the ultimate one. It's like you can operate these things at 40, 50, 60, 80 volts, which is insane, and you still can operate at many tens of gigahertz, right?
Yeah, it's crazy.
So it's interesting, but I think GaN is one of those interesting materials because there's still a lot of active research being done. And this is the first I've heard of complex digital circuits being done with GaN. Maybe it's just because I'm not in this particular scene. I don't know what activities been going on.
It might just be pie in the sky stuff. It might not be.
Yeah, it's probably some DARPA project, right? I'm sure DARPA is all over this stuff because this is right up their alley, right? You can use this to do phased array radars and high power.
Yeah, there was a lot of defense stuff at this conference, for sure.
Absolutely, but it's fascinating.
Environmental stuff too. So it was cool.
Fascinating and incredibly expensive.
There you go.
But I do know, I think you can buy GaN devices now, and people are using GaN devices for cell stations. I think cell sites might be using GaN now. Somebody who works in this area should correct me if I'm wrong. But yeah, really cool stuff. Gallium nitride is cool, and silicon carbide and some of those other technologies are cool too, but I think people are really latching onto GaN as being the hope for tomorrow, for getting really high power densities, right? Really high power devices in small spaces. And I think maybe the concept of making complex integrated circuits in GaN, it might be the big deal right now, right? That sounds to me like that's what they're working on. Cool stuff.
And that segues us straight into Chris's Chip of the Week.
Chip of the Week. It's been a while. We haven't done this in a while.
No, we haven't.
And it's not even a Chip of the Week.
That's
no,
right.
It's not.
That's true.
It's a transistor. It's not even a transistor of the week. It's a package of the week.
Right, but it's Chip of the Week for whatever. I just like it. I think it's cool.
That's fine. That's the only requirement for this show.
Is the Chip of the Week Arduino?
No,
goodness.
That's not a chip. First off, that's a platform, and second off, stop saying that. No, so Chip of the Week. So I was looking at some stuff in International Rectifier, who was actually presenting at this conference, but it wasn't at this point. And so if people work with high power MOSFET stuff, and they like going smaller than bigger, if you're going with bigger transistors, you get more safe operating area kind of behavior. But when you start going smaller, you start running out of options. You have the what is it? The DMOS. Schutzky. What's it called? The D squared pack. That's what it is.
Yeah, D squared pack.
Yeah, D squared pack.
Right. And so that's if people don't know what I'm talking about, it's it looks like almost like a TO220, which you fold it over and then solder directly down with a thermal
surface
actually
mount.
tabs chopped off.
There's surface mount and big honkin' metal tab on the back, exposed pad on the back.
Right. So you have to heat sink that to your board.
Yeah.
So that's a big deal. For a lot of people, if you have sensitive components anywhere else on the board, and you start seeing thermal gradients across the PCB, you can really start running into trouble. Mm-hmm. So this is a cool idea, though. So IR has this different kind of packaging where it's basically it's the same die. It's the exact same silicon die, or I guess eventually it could be silicon carbide or GaN or whatever else. But then they have this metal chip scale, but not exactly chip scale kind of package, basically, and And the advantage of that is pretty cool. You know, you could stick a heatsink directly on top of this bare metal chip. It almost, you know, the best kind of comparison I have is looking at like a crystal oscillator, how those come in those gold packages with like the four pin pads. It kind of looks like that, except it's for a transistor now.
But it's surface mount. The actual outer metal package itself is surface mountable, so that you don't have to put a heatsink on top. You can use the PCB as the thermal heatsink. So
correct, yeah. So yeah, you can use the pad. You know, heat can come out through the pads as well to like a thermal pad on the board, or then you could stick a thermal heatsink on top of it, and then you could suck heat out the top of this metal can, and it's pretty interesting. I think it's a cool way to do it. You know, you start seeing some pretty significant thermal dissipation advantages, and you know, I haven't designed any in yet, so I don't know about how you actually, you know, it's different now because instead of having instead of bolting something to a heatsink, which at least I'm used to, you know, you bolt something directly up to a big metal heatsink. This is now you kind of push a heatsink down against something, so it's horizontal now instead of vertical.
Right,
but I think there might be something that's a little bit different about these packages too, because do D-squared packs and packages like that, do they use flip chip technology inside, or are they bonded out like an ordinary chip?
No, they're actually bonded out, I believe.
Yeah, so this is different because this is using flip chip, right? The whole reason that you can heat sink directly to the die is because you actually have the die turned over so that you're bonding out the bottom, right? And you can actually attach a heatsink directly to the bottom of the die, which is now the top of the package, right?
Yeah,
I think that's the significant technical innovation behind this package. Is that
right? So if you're looking at a silicon wafer now, you have the substrate. Usually in silicon wafers, you have the substrate of silicon, and then you process on the top of the substrate. Like you'd plant stuff and you deposit stuff, whatever. And now the heat sink is effectively on the bottom. Silicon. It's directly touching the silicon substrate where the heat is going usually.
Yep.
And yeah, I agree.
And in this case, you're turning the die over once it's finished, and you're connecting the leads of the package directly to the pads on the die using, who knows, some flip chip technology that's not bond wires. And then what that lets you do is it lets you put a heatsink on top of the package, which is the bottom of the die. So you're flipping things over, which that was always. I always get a kick whenever you see like a plastic package, like a QFN or something, and somebody's put a big fat heatsink on the top of the plastic package. Like that does nothing.
Oh well, no, it helps.
Well, okay,
helps.
Sure.
It does help.
Nothing
Trust
does
me.
nothing. But if you think about it, compared to actually having something
its
that's
thermal impedance is high. Yes,
is very high.
Yes, of course.
Yeah.
But
packages are very high impedance thermally. Yeah. So. Anyway, so I think that's probably the reason this is such a significant advance is that if flip chip is making its way, like flip chip used to be an exotic technology, but now if like power MOSFETs are using it, that's more of a mainstream application. So
well,
that's
if you
cool.
want some direct numbers, this new DirectFET 2 package has 8.1 degrees C per watt compared to a D-squared pack, which has 16.8, so double. So it's half. It's half of the thermal impedance of a D-squared pack, which is kind of like the industry standard surface mount power package. So it's actually twice as good.
So now you're going to be able to have 200 amp rated FETs that are impossible to actually use at 200 amps. Because you can't make the traces to them wide enough. But you'll be able to get the heat out. That'll be great.
Our amp hour is up, fellas.
Oh, wow.
Do we have any dregs?
Dregs of the amp hour. Oh, I don't know if you want to talk about Did you see the thing that someone sent in about the Shonky product of the week?
Oh, I haven't looked at it. Is this number?
Oh my God, it is.
So
Ben Rampling sent in a Shonky product of the week, and it is fantastic. This is by far the best one I have ever seen. It's a guy pushing a earth grounded mouse pad and foot pad for when you're sitting at your desk. It is almost like you just have to watch it and just like your jaw will drop. First off, the guy has like the craziest hair and he's standing in front of.
He's a cool looking dude.
He's in front of a fireplace too. But then she starts talking about attaching himself to a multimeter, which then has some kind of FFT conversion that goes to a screen, and just like the ridiculous things he's saying about the FFT, like he's showing an FFT plot from 0 to 1 kilohertz, and he's talking about all this harmful radiation that's coming from the atmosphere, and once he puts his feet on this grounded pad, it goes away.
I'm watching the video now.
You're
And
so
there's
safe,
books.
and you should say, oh, and he even, and as Ben wrote into us, he said he even drops the term, you get the electrical nourishment of the earth once you put your feet on this grounding pad.
My favorite part of this video is the fireplace in the background.
Oh yeah,
No,
I think that's
check out his
spectacular.
bookshelf. His bookshelf.
Oh, that's
good, too.
He's got
That's
like
his other products.
thyroid
That's his other
research
products.
books. You know.
Oh
yeah.
yeah. Oh, it's amazing. I want to see their sales numbers and like their
Right.
return policy. You know, like
Yeah.
oh, it is by far like Ben. This was just spectacular. I am so glad you sent this in, and you're just watching it through, and you're just like, I think it's at one point he says, like that the radiation that you're receiving can cause some kind of defect in children or something like that.
This is interesting. If they sold this in Australia, they might be in trouble because on the EEV blog forum, somebody put up the link. I'll have to get it, I think, where somebody sold this power bracelet. Right, it was like a bracelet that had some holographic thing in it, and it made you. Yeah, it made your balance better or something like this. And there's even a photo of Bill Clinton wearing one, right? So he got sucked in, right?
Oh, man.
But the Australian Competition and Consumer the ACCC, they actually they got a complaint about this thing that, it was bogus, it was a sham, right? They actually investigated it and made them take out, ads in the paper, made the company take out ads in the paper saying, sorry, we have no evidence for this, it's basically bullshit.
Oh, that's awesome.
And offer everyone a refund. They force them to do that, and they fine
wow.
them and for these shonky
Wow.
products. I'm not sure if that happens in the US or not, but it certainly happened here.
That pretty much never happens
Which
in
is
the US.
right, freedom and
Yeah,
all that
that's-
shit, right?
Yeah,
freedom.
we
You can shoot as much as you
support
want.
we support snake
Yeah.
oil here in the
Right.
US. Yeah, that's like
Yeah.
the entrepreneurial side of
Yep. No, they will nail your ass to the wall here in Australia, so you got to be careful. Yeah.
Wow.
Another
And
plus one
they
for-
make you
for,
print a
yeah,
public
Kangaroo
apology in
Land.
the paper saying our product is bullshit. It's great. I love it.
That is great. That's
And
really
I
great.
like how the video's got 76 likes and 129 dislikes. so it is in the red.
It's just such a great video. So
but-
I love, and it's
But
ADHD
it's so
that he's
well
claiming
done,
in
though.
kids.
It is well done. It's
No, it's not well done. Oh, it's horrible. It's the
Come
guy's
on,
just like.
for the gullible public.
Can you imagine getting stuck talking to this guy at a party? It's just like the guy you want to punch in the nose.
Yeah,
let me
but
tell you about my new product.
But the public lap that sort of shit up, right?
yeah.
Joe Public would absolutely lap it up, I'm sure.
I don't know.
Anyway,
At some points, I'd say, "Oh, the public deserves it if they don't know." But at the other point, I think about my grandmother watching it and be like, "Oh, well, of course I need this." Like it's only $20. That's the kind of thing that I think about. So
And it's available from the Longevity Warehouse.
Wow.
If they're in Australia, they wouldn't be. They wouldn't have much
Yeah.
longevity.
that'd be the Brevity Warehouse.
Oh, you can buy the Radiation Protection Super Pack.
Yep.
I'm sure it comes with a tinfoil hat.
Yep.
Anyway, that's great. Thank you very
Yeah.
much. Who sent it in?
Ben
Ben,
Rampling.
thank you. That's
Oh,
awesome.
it's spectacular.
I'm sure we can top it next week.
Yes,
There's
exactly.
There's no
People
end
should send
to
in.
the
Yes.
to the scams out there. Really, it's just yep. And it's so easy to use technology, and something like an FFT that is using here to to prove that
It's sciencey.
It's sciencey. Yeah, exactly.
Yeah.
It's so easy to do it. Oh boy.
Yep.
Snake oil.
Well, thanks, Jeff. We
Yes,
always
thank you
love
very
having
much.
you on. The
Thanks
Arduino
for,
crowd might come, or the anti-Arduino crowd might come
Yep.
for your head on a stake. But,
Well, send them my way. I can
yeah,
deal
okay.
with them. Yeah.
okay.
Right.
Well, don't worry. I hear you move around a lot, so you can. They'll never be able to find out where you are.
Well, thanks for having me on the show. It's always a lot of fun. And
Oh, yeah.
It is.
maybe next time I'll be in a more acoustically compatible environment. But hopefully it's not too bad.
Okay.
I've still got this guy's voice going in the background. Oh, jeez.
Don't keep watching that because you might start believing it.
Yeah, exactly. Yeah, he's got a good message.
Oh, he's using a Radio Shack multimeter.
He does have very nice hair.
He's a pretty cool looking dude. Yep. You've got to believe him. He's got one of those power amulet necklaces. Like.
That fireplace sure is cozy.
Yeah.
Mm-hmm.
I think it's one of those gas ones.
It's
not
probably a
real
TV
ones.
screen. There's a TV screen in there.
Right.
Anyway. Well, thanks, guys.
Brilliant.
All right.
Thanks, mate.
We'll talk to you guys next week.
See ya.
Bye.